Hi guys, I am Pratyusha and today I'll walk you through some simple algebra questions as part of the GMAT prep for the quantitative reasoning section. So let's start with our first question. When X liters of water was added to a container that was already filled to 1/3 its capacity, only 2/9 of the container remained empty. In terms of X, what is the capacity of the container? So we need to find the capacity of the container. Okay. We begin by assuming that T is the capacity of our container and we need to figure out T in terms of X. We're given the X liters of water added to the container which was already 1/3 filled. So X plus 1/3 of T is the volume of water in our container, and we are given that 2/9 of the container remained empty. That means that T minus 2/9T, that's 7/9T, is the volume of water in our container right now. So equating both of these expressions, we get X plus 1/3 of T is equals to 7/9T. Taking X on one side and T on the other side, we get X is equals to 7/9T minus 1/3 T, that is 4/9T. But we need T in terms of X, so we cross multiply to get T is equals to 9/4X, which is our option D. Okay, hope that's clear. Let's move to the next question. Two negative numbers are such that their product is 160 and the smaller number is 4 less than twice the greater number. The greater number is, let A be the smaller number and B be the greater number. We need to find the value of B. We're given that the product is 160, so A into B is 160, and we're also given that the smaller number is 4 less than twice the greater number, so A is equals to 2b minus 4. By plugging this expression into this equation, we get 2b minus 4 into b is equals to 160. By dividing by 2 on both sides, we get b into b minus 2 is 80. So we either solve this by opening the brackets, converting it into a quadratic equation and factorizing it. We get two values of b, that's b is equals to 10 or minus 8. But we're already given that both a and b are negative values, so we get the answer as b is equals to minus 8. Or we plug and play, that is, we look at the options that are given for the values of b, that's minus 8, minus 16, minus 10, minus 20 and minus 4. We put it back into this equation, that's b into b minus 2, and we check if it satisfies the equation. So if it's minus 8, so minus 8 and into minus 8 minus 2, that's minus 10. Yes, we do get 80, so this does satisfy the equation. And if b is minus 16 into minus 18 is definitely not 80. We need a 0 digit at the end of it, right? If b is minus 10 to minus 12 is 120, that's not 80, and similarly none of these values satisfy, so we land at the answer, that's b is equals to minus 8. That's option A. So that's one quick way of solving the questions. Let's move on to the next question. If x and y are integers and 2x minus y is equals to 11, then 5x plus y cannot be, okay. We begin by assuming 5x plus y is an integer n. We're given that 2x minus y is 11. By adding both of these expressions, we get 5x plus 2x, that's 7x, plus y minus y gets cancelled. We get 7x is equals to 11 plus n. And taking 7 to the denominator, we get x is equals to 11 plus n whole divided by 7. Again, we can do the plug and play method here. Okay, we're given that x is an integer, right? So for x to be an integer, we need that 11 plus n has to be a multiple of 7, because if it's not, we'll be left with a fraction value, right? So we plug in the values for n that's given in our option. That's minus 4. 11 minus 4 is 7. Yeah, 7 divided by 7, that's 1. You get x as an integer value. 11 plus 3, that's 14. Then you'll get 14 divided by 7, that's 2. You again get an integer value. But when we plug in the value of 12, we get 11 plus 12 is equals to 23. So 23 by 7 will give you a fraction, and thus that is not an acceptable value for 5x plus y. 11 plus 17 again, 28. 28 by 7 is 4. That's an integer. It's acceptable. 11 plus 52 is 63. 63 by 7 is 9. That's again acceptable. So of all these options, only option that's not acceptable for 5x plus y is 12. That comes out to be option C, and hope this was helpful. Thank you for watching. Bye bye.